Welcome to Who Wants to Be an ACP? You're looking to get ACP certified? If you are, definitely go to agileprinciple.com. It's your one-stop shop for ACP certification. We got a question in from some of our friends who are on the program. And the question is about estimating in an agile environment. Let's talk about estimating. In the world of Agile, the way we estimate is rather different. And I want to go straight into our presentation to unravel how this is done. So on the screen, we have the ideal time for a basketball game. So it shows 8 minutes and 36 seconds. How much longer do you think this game will run for? 8 minutes 36 or something different? If you said something different, you're right. How much more? Some people go as far as saying, oh, it's going to be another 25 minutes, so it's another 40 minutes. And they're not wrong. The way we look at ideal time in the real world in a basketball game is the same way our clients look at ideal time when we make promises to them. So you make a promise to a client, oh, that will take me 8 days. What happens at the end of 8 days? They're looking to hold you accountable. So what do our stakeholders do with our estimates? They ride hard on top of the poor team member, putting their foot down and holding you accountable. So we don't do this in the world of Agile, right? We estimate differently. The first thing is you don't have to use this technique to consider yourself an Agile team, because I'm going to be showing you a couple of techniques. You can estimate as you've always estimated, but I'd like you to get this understanding. The understanding of how it's done by many Agile teams. Maybe you'll see that this could be much more effective and much more accurate as a result. So let's examine, why would we want to estimate differently? Well, in Agile, like I said, we don't like estimating by time. It's very difficult to estimate in time. And you might ask, why? What's the problem of estimating in time? Well, let's go through a couple of scenarios. Taking a look at this board one more time, right? You would want to estimate how much time left, and you would say 8 minutes, 36 seconds. So the actual game, right, is 8 minutes and 36 seconds, right? The actual, I should say, the ideal time. But how much actual time is it going to take to complete the game? As in my example, you have fouls, you have timeouts. So when you think about it, things are going to happen. In the same token, in the real world, stuff happens. It's never exactly as planned. But one thing's for sure, this game is going to get done today, right? If we look at a wider time box, a more flexible time box, we understand it's going to get done today. It's just not going to get done in 8:36. So we're talking more about predictability, right? The ideal time means if you count the exact actual time that you do the work, that's one thing. But calendar time is something else. Let me give you an example. So it takes 40 hours to carry out a task. We have a 40-hour work week, but that individual isn't working fully on that task for 40 hours straight. They're doing 2 hours this week, 5 hours next week, 2 hours another week, like that. And that's why in the world of Agile, we understand these frailties of time, right? Let's look at a scenario where someone comes into the office and says, hey, can you build this for me? You're going to be thinking, okay, I've done it before. It's really not that difficult. It's going to take me, I should be able to get it done in 3 days. Now, I say 3 days, and the person is going to be thinking what? 3 calendar days. So you're setting the expectations that this thing is going to be done in 3 days, and it won't. It's not going to be done in 3 days. because I'm working on 5 different projects and I've got to take my dog to the vet. I've got to take vacation. So it's not going to take 3 literal days. It's going to take considerably longer, right? And I know that as soon as I say 3 days, people are going to be thinking, oh, it's going to be done by XYZ date. So what do? I need to protect myself because I know the expectation is 3 days. So I pad. We all do this. We pad our estimates, right? As someone who develops content and solutions, what I used to do back then was just multiply my estimate by a factor. So 3 days could become 9, and it no longer represents the actual amount of time to get the work done. Instead, it's representing a guesstimate of a calendar based on all the other priorities. So what do? I take that and I hand it to the PM, right? In the world of traditional, and the PM takes that even further. The PM might even double or triple that again. You get what I'm saying? So we end up doing all this bad stuff. It gets padded. The PM is just as guilty. The developers, they understand the game in the company, so they pad. Everyone pads. That's not good. So there's a better way to do this. And that's where story points come in. Story points are not based on time. Let's think about that. Story points are not based on time. They are based on the size and complexity of the work. So enter story points. Not based on time. Story points instead factor in complexity. They factor in effort for sure, but they are not based strictly on time. When a team of developers in an agile setting are doing this, what they are likely to do is say, can this be done in the box of the sprint or not? It's a very higher level way of thinking, right? So on the screen here, what they would do is have a reference story. And they would ask, okay, based on the reference story, is this story bigger, smaller, or the same size? If it's the same size, it's that same estimate. If it's bigger, in economies of scale, the team decides how much larger it is, okay? You got to understand that we use relative sizing mentally to look at a story and say, it's as big as this one we know is a 5, so it's a 5, right? Now, moving on beyond this, let's go into plan in poker. Plan in poker, the way it works, each estimator has a deck of cards. The team chooses a small story and assigns a value as a baseline. The product owner describes the story and allows for brief discussion. Each player selects a card, and at the count of 3, 1, 2, 3, all cards are shown at the same time to reduce influences. Outliers discuss the differences. They re-estimate until convergence. And after they converge, they move on to the next thing, right? But you got to remember, our stories do not represent time. There's a different way of doing this. The second way, in addition to planning poker, as opposed to doing planning poker, you could say, okay, we want to do affinity estimating. In affinity estimating, the most important thing is to understand the concept of seeding the wall, right? Or seeding the board. After you have seeded the board, and we have examples of an extra small story, a small story, a medium, a large, an extra large, the team could come into this armed with a lot of stories to be decided upon, to be estimated, right? And the way it works is each team member takes the story that they're looking at and puts it in one of these buckets that best fits. It is very, very rapid. It's so rapid that you could get done with estimating 100 stories in minutes. But when the event is over, or when you're at the end of that first part, the team now looks at what has been estimated, and they could critique, they could challenge, they could say, well, this is in medium, I think this should be an extra large. So there's that dialogue going back and forth until there's an agreement, and we move on. We move on. And for the real world, I would say if you're doing this in the real world, break it down into short bursts of maybe 5 minutes so that the work doesn't become so much that you've got a lot to critique. Just do it in little batches of five minutes and see how far you go, and then critique immediately and then move. And then when all is said and done, you got to remember, very similar to the Fibonacci sequence, extra small on the back end could mean something else. We just don't have it explicitly, but on the back end, we could have a 1, we could have a 2, we could have a 3, we could have a 5, we could have an 8, because the numbers in the Fibonacci sequence, 1, 2, 3, 5, 8, 13, so on. Now, even though we're not seeing these numbers, when we are using affinity estimating, the numbers are on the back end, right? So whoever the facilitator is, when all is said and done, it's up to them to do a final calculation based on all of the stories that are done, to put labels on them so that you can actually track velocity and so on. So for those who are new to this, it could sound rather abstract. I agree. But for those of you getting ready for the ACP, I'm really hoping that this makes sense. So let's have a quick review at a high level. Agile estimations aim for relative estimates, relative effort, rather than precise timeframes. Planning poker, team members estimate story points anonymously using a Fibonacci sequence, and they discuss outliers to reach a consensus. So when you do the planning poker, if there's any outliers, let's discuss, let's understand, why are you saying it's a 21 fail and someone else is saying it's a 1? Then the second way, affinity estimating, also known as t-shirt sizing. This is where we assign simple sizes, extra small, small, medium, large, extra large, to user stories based on relative effort, extra small, small, medium, large, extra large. And we really use the process of relative estimating. We're comparing the stories to a reference of known effort and estimating the story's relative size. This is what we use in both planning poker and t-shirt sizing, or affinity estimating, same thing. All right, I hope this clarifies it for you. If you're still stuck, we may need to have a deeper conversation, because I really didn't go as ABC as I could have, because I'm believing that you already know this. So this is kind of more like reinforcement of the concepts that you already know. All right, thank you very much for the question. I look forward to getting another question from you in our next episode. Bye for now.